Hi student, good morning. It's morning right now. I am recording this video at 9:16 a.m. Of course, Malaysian time. So today we want to look at how to solve this problem here. What's the problem? Let me just write it down for you. Okay, so the problem is fx equals to x squared minus exponent negative x. Now, this is one-dimensional or scalar equation. Is it linear or nonlinear? You can see we have x to the power squared here, and we have exponent negative f. That makes this problem nonlinear. Okay, this is a nonlinear scalar equation. So the question here asking you to solve this problem. Now solve here means finding the x values. Okay, in other words, we want to find the roots for this equation, for this scalar equation. What are the available roots? Okay, so since this is nonlinear scalar equation, we're going to use numerical method to solve. Now there are three methods that can be solved for this problem. So the first one, we call it bisection method. The second one is secant method. And the last one, anybody want to guess? Yes, it's Newton method. Okay, Newton method. So these are the three, we call it iterative method. Iterative method. Okay, now if you don't want to use iterative method, you can find x by producing the graph. Okay, producing the graph of it. So let's we can, by quick search, I can actually look at producing this graph using Desmos. I like to use Desmos calculator or graphing calculator. Yeah, this one. Okay, scientific calculator, or this is the how it looks like, Desmos. So to plot it, there's another one which is called a graphing calculator. Okay, there you go. This is the one we want. Okay, so let's put the graph y equals to x squared minus exponent negative x e to the power of negative x. Okay, so this is the graph looks like for this problem. X squared minus e to the power of negative x. Let's say I want to set interval of x from 0 to 1. So 0, x from 0 to 1. So if we look at here, this is the interval where the value of x from 0 to 1. Okay, so from this plot here, so your plot for this problem, so if I can sketch it now, so we can see that -1, okay, we have -1 here, and this is 0, this is 1, is it 1 1? Okay, now 1 2 3 4, so I can say this is what, 0 0.2 0 0.4 0 0.6 0 0.81. Okay, somewhere in between here. Let's see, somewhere in between here to here I have this graph here. Okay, so maybe, okay, so what is the root? Root is when this is my x, this is my y, and then, or my, if the question say is your fx. Okay, if you don't want to write y, you can write it, this is your x and y. So when, what happened to the roots? The roots, you can find the roots when fx equals to 0. Okay, so when this is 0, I have, this is my one of the root, which is my x value. Okay, you can see that the roots lie somewhere in between here, which is from 0.6 to 0.8, let's see. Okay, so the root lies in the interval 0.6, 0.8, somewhere in between here. That's the root. So how can we find the exact value? How can we find the exact value? So to do that, we can use bisection method. Okay, we want to use bisection method, but bisection method uses something called bracketing. Okay, it's called bracketing, where it will start. So the idea of I'm going to give you the idea first, and then we're going to use Scilab to do this. Okay, so the first step for bisection method is find two values of a and b that satisfy the intermediate value theorem. Intermediate value theorem. Okay, so in this case, let's say we wanna focus on this value. So the interval that we wanna consider is 0, 1. Okay, so which means now I can say that my a equals to 0, b equals to 1. That's it. We have two values of a and b, that value must satisfy the intermediate value theorem. Now, what does intermediate value theorem say? Okay, if you forgot, what you do here, you satisfy for this function here. Let's say in this value a and b, we want to test and see whether the root exists or not. It's very important to identify whether the root is in that interval. Else, that'll be a waste of time. Whatever you're doing, it will be a waste of time. Okay, so let's check and see. So we have fx equals to x squared minus exponent negative x. Now the intermediate theorem say that if f at a multiply f at b and they are less than 0, then there is a root. The root exists in the interval AB, which are AB. Okay, you can do a quick check. Start with a f of 0. So I have 0 squared minus exponent negative 0. So 0, e to the power 0 is 1. So I have negative 1. Okay, and then f of 1. I have 1 squared minus exponent negative 1. Okay, what is 1 squared? 1 minus exponent negative 1. Okay, so use your calculator. 1 minus xe to the power of negative 1. 0.6321. Okay, so there you go. 0.6321. Now what is f0 times f1? We can see that when f of 0 multiply f of 1, which is this value here. -1 multiply 0.6321. You don't even want to solve this, okay? You just want to see that there's a negative sign, so it's less than 0. Then there exists a root. So that's the first step that you find out. Okay, now what is the second step? The second step, step number 2, is find the value of c. Find the value of c such that c equals to a plus b over 2. So 0 plus 1 over 2, which is 0.5. Okay, now once we have obtained a, b, and c, step 3. So step 3, find f0, which is already fine, f1, and f0.5. Okay, so we've already done that. We have done f0. We just got to find f of 0.5. So what is f0 that you have obtained? -1. What is f1? Which is 0.6321. Now what is f of 0.5? So this one. So I have 0.5 squared minus exponent -0.5. Okay, so you should get -0.3565. Okay, let's check this. 0.5 squared minus -0.5. Remember, to do squared, you just use shift and the upper triangular. Okay, this is what you get, -3565, right? I'm taking 4 decimal places here. Okay, that's good. You have obtained, I have obtained FA, FB, and FC here. So what is step number 4? Okay, step 4 is, now I gotta check if FA times FC less than 0, then we're gonna set A equals to A, B equals to C. Okay? Else, meaning if this is greater than 0, we will have A equals to C, B equals to B. And then we repeat the process. Okay? So from our calculation earlier on, what is FA times FC? So FA is -1. So we have F0 times F of 0.5. So I have -1 multiplied -0.3565. So this is what I get. So I'm positive they are greater than 0. So what happened for my next iteration? My A will become 0.5. My B is the same, which is 1. Okay, now we gotta continue the process. What are the process? This one, step 2. Okay, find the value of C. So I can find the value of C now with the new values. So, okay, I can say this is the second iteration now with A equals to 0.5, B equals to 1. So what is C? A plus B over 2, which is 0.5 plus 1 divided by 2. So you can get 1.5 divided by 2, 0.75. So that is my C, and the process will continue. Okay, let's do some. Okay, so now I'm going to show you how to actually find the root that lies in this interval, somewhere here. Okay, by using Scilab. So let's do that. So I need to open my Synode here. Okay, this is my Synode. So let's write a command saying that finding the root of fx equals to x squared minus exponent negative x. Okay, so once we know what we want to do, so what we want to do here, first of all, we want to do bisection method, right? So we need to define the interval. Define a and b interval. Okay, so a equals to 0, b equals to 1. And then we got to find c, but c changes. Okay, first iteration, second iteration, c changes depending on the condition that we set for this condition here. If fa times fb less or equal than 0. Okay, then what happened? Not less than equal, it's just less than 0, then the root exists, right? So we gotta find this one. Fa times fc less than 0, then we gotta set this if and else in this loop. So we need a for loop here. For I equals to 1 to k. Okay, let's say k. So here I'm gonna find my c, which is a plus b over 2. And then let's have this if statement. If, okay, we have a function, so I need to define my function. Okay, so that's good to know. So let's do that first. Fa times Fc. Okay, if Fa times Fc less than 0. What happened then? This is what happened. A become A, B becomes C. Okay. A becomes A, B becomes C. Okay. Else, now else here automatically means if it's greater than 0 here. So A will become C, B will become B, and then you end this for the if statement. Okay, you end the if statement. That's pretty good. Now let's define a function here. So I'm gonna write the function all the way up here. Define the function. Okay, when I say function, that means I need to have a function file. Okay, so what we do with the function file, you need to say begin function. So function y equals to f of x. Now this y, the function is x to the power of 2 minus exponent negative x. Okay, so once you have f here, meaning it's gonna evaluate for fa and fc, and then it's gonna give you the answer. Okay, what else we want to do? We haven't defined what is k, how many iterations. Okay, so now we want to define k. How many iterations? Let's say 100, because I don't know at what iteration it will converge, right? Now, how you want to display this? If you want to display this in the form of table, then we need mprintf. Okay, so mprintf here, what I have is I want to display all this. S here means character. Okay, so what are the character? Let me just do it, and then I'll tell you what the character I have. Okay, so let's have 4 here. Maybe I need more. I don't know. I'm just gonna write it down. How many I need? Okay, so the first percentage here stand for my k, my iteration. Okay, and then the second iteration here stands for my a interval. And this one stands for my B interval. And this one stands for my C interval. So 1, 2, 3, 4. I must have 1, 2, 3, 4. And then the other one is my root, where my root is as FC. FC, that's the root. Okay. So let me just tell you. If I have 5%, 1, 2, 3, 4, 5. S stands for characters. So I'm going to display this characters. I must have 5. Quotation 1, 2, 3, 4, 5. Okay. Now what you're going to do here, I'm going to copy this and put it somewhere here. Okay, but instead of S, now D for integer. Okay, so I need to have a quotation. Okay, so a quotation from here to here. Okay, and then similarly for this one, I need to have a quotation from here to here. Okay, so for A here is a decimal point, so that will be like 2 decimal points, so 2F. Similarly, this is 0.2F. Maybe we'll just stick with 4 decimal places, okay? 4F and 0.4F. So if you wanna this K here now, you wanna whatever K that start from I equals to 1 is gonna display as an integer here. So you got to remove the quotation now. Okay, because the quotation stands for character. You wanna display the word K as in the form of table. Okay, so I need to have a /n, which means new line, so that it don't overlap or continuing. Okay, so you need to have /n here. And then what else? I think that's it. Let's try this. Okay, if it's an error, we'll edit it. Okay, so save your file as bisection. Okay, bisection. Okay, let's see what we get. I'm gonna run it again. There you go. See that? So this is what I have. K. Oh, this is weird. K is under. So I gotta change this value here. I equals to 1 to K. Okay, so obviously I need I, not K. Okay, I can fix that. And also one thing I can realize that they are too close to one another. See the character here? I need to put a space. To do that, so just start with 2, just put a 6 space, 6 space, 6 space. You can adjust it later on. Similarly here, 6 space, 6 space, 6 space, and maybe 2 here. Okay, let's run it again and see that how it goes. Okay, A, you need to adjust A and C a little bit. So I'm just gonna put 4 starting with A. Okay, let's try that now. Is that good? Think it's okay, right? Okay, what happened here? We can see that the root converges. What do you mean by converges mean? Look at that, it gets 0. So when fx is 0, meaning when fc is 0, that's my root. So starting here, you can see that 0.735735. So that's my root at C. And we know that it's going to be somewhere in between 0.6 and 0.8. Okay, and you can see that it converges at C equals to 0.7035. Okay, but I'm going to edit this. Okay, I want to edit this because this is not, I mean, it's okay, but you have to see through the convergence here. You got to find it. Oh, it actually stopped at 15 iteration. It does not require more than 100 iteration, right? So what you can do, you can put an epsilon or the convergence test here. So let's put the convergence test here. So let's say I want it to stop at the convergence. This is my this is for my convergence test. Okay, so what happened here, all the way here, I can say that if absolute fc Fc less than epsilon. Then break. Okay, and I have an end for if. Okay, do you see that? So meaning I'm saying that if epsilon is 0.001, so Fc is 0.001, then you stop the iteration. Okay, let's see that. What do you get? There you go. Okay, there you go. So my root is my C value here. So it requires 13 iterations. So I can actually add this thing if I want to. So I can put an mprintf. Okay. The root x. The root x is %.f for f. Okay, 4 decimal places. C is my root. Okay, the root x is and required only %d iterations. So that refers to my I at the end. Okay, so it says that the root x is this value here for my C, the end value for I iteration. Okay, let's do that and see how it comes up. See, the root x is 0.35 and require only 13 iteration. Okay, guys, so this is how you solve using bisection method. I mean, using Scilab to find the root. Okay, the code is not complicated at all. All you gotta do is you gotta understand this work here, and then you can easily apply that. Okay, see the second iteration C is 0.75, which is obviously you can see that here. Okay, so that's all. I will might try again for secant method. So stay tuned for my next video. Bye for now.